Geometry Standard 9. We're going to look today at our last transformation, which is a dilation. The difference is that if we translate, reflect, and rotate, the first three we've looked at, they give you the image, and then the pre-image give you a congruent shape. Dilations are going to give you similar shapes. And remember, similar means proportionally the same shape, but not the same size. So you're either going to make that shape larger or you're going to make that shape smaller. So we're going to start with some vocab here. So what exactly is a dilation? So a dilation is a transformation that either enlarges or reduces the size of the original figure. And to dilate a figure, our math, we're going to do over and over here, is to multiply. So multiplication is what we'll mathematically do to be able to do our dilations. I'll talk a lot about scale factor, ratios, proportions, however you learned it in previous years. A scale factor is a ratio of the corresponding sides in a figure. And you always put the new or the image on top and then the original, or known as the pre-image, on the bottom. If that scale factor is greater than 1, then that means the figure is going to get larger, to enlarge. And if the scale factor is less than 1, that means it's going to reduce the size of the figure. We're going to start by just trying to find the scale factor that was used to create the dilation before. So this is your image, or the pre-image, and then this is the image. Or we could call this is the original and this is the new. So if we refer back up here, you're going to put the new on top, or the image on top, and then the pre-image or the original on the bottom. So corresponding sides to corresponding sides. So this would be 10, and then that corresponding side would be 8. So 10 divided by 8, or just reduce the fraction. So I'll reduce it first. So divide by 2 will give us 5/4, or if you like your decimals, 5 divided by 4 is 1.25. If you want to make sure that we're right, we could check another side. So we have these two sides are corresponding. You're going to do the new, or the image, on top. So 15/12. And then think about what we should divide by. So if we divide by 3, that'd give us 5 on the top and 4 on the bottom. So notice it shouldn't matter what corresponding sides you use. They always are going to get the same scale factor. That means they're proportional, which means they're similar. Again, so we could try, let's go this one to this one, which is the same as this one, because it's a rectangle. So new one, so in this case would be 8 over the same one would be 12. So 8/12, we divide by 4, that gives us 2. Divide by 4, that gives us 2/3. Or if we go with the other corresponding, so new over the original, 18. 12 and 18, you can divide by 6. So 12 divided by 6 gives you 2. 18 divided by 6 is 2/3. So the scale factor is the same no matter what pair of corresponding angles you want to use. A little bit more vocabulary. So if you're given the scale factor, so instead of me going to find it like I just proved, if you're going to be given the scale factor, so you're going to dilate a figure on a coordinate plane by multiplying the x and the y values of each ordered pair by the given scale factor. So if the scale factor is 4, you're going to multiply both the x coordinates and the y coordinates by 4. If the scale factor is a half, you're going to multiply the x coordinates and the y coordinates by a half. Describe what would happen if the scale factor was greater than 1. So you're multiplying times something greater than 1. That means the image would be enlarged. And what describes what happens if the scale factor is less than 1. That means if you're multiplying by something less than 1, then the image would reduce. And it doesn't ask this question, but if you're going to multiply by 1, of course, the image isn't going to change any size. Same shape, but no change in size. And we just went over this, but just make sure you remember, if you go to find the scale factor, You got to set up as a ratio. So this is above was given the scale factor. This is to find a scale factor. It is new over the original or the image over the pre-image. So always remember to put the new one on top. Okay, let's try to actually dilate. So we're given a scale factor of a third. I need to write down all the pre-image points. So A, B, C, and D. A is at -6 and 3. B is at 6 and 3. C is at 6 and -3. And our lovely little D over here is at -6, -3. So again, remember when you are given the scale factor, the only thing you have to do is multiply the math times 1/3. So 1/3, I'll write those down quick. So 1/3 times -6 is -2. 1/3 of 3 is 1. 1/3 of 6 is 2. 1/3 of 3 is 1. 1/3 of 6 again is 2. 1/3 of -3 is -1. And 1/3 of -6 is -2. 1/3 of -3 is -1. So let's go ahead and plot those points so we can see that we're going to reduce this to a scale factor of 1/3. So -2, 1, that's A prime. 2, 1, that's B prime. C's at 2, -1, whoops. And then D's at -2, -1. So we're going to connect them. The size should be smaller because we're multiplying by a number less than 1. And it still should have the same shape, but of course a different size. And then algebraically, first time seeing this, you're going to put your x comma y yields. And then all you did mathematically is just multiply. So you took 1/3 of the x, or taking 1/3 times x, and 1/3 times y. Okay, compare the ratios of the corresponding sides. What do you notice? So I'm just going to pick, let's go DC, this big side here, and the D prime, C prime. So I'm going to put D prime, C prime on top, DC on the bottom. Remember, it's new over original. DC is 1, 2, 3, 4 length. DC 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, if I take 4 and 12, the common factor is 4, so we can divide by 4, which would leave me with 1/3, which shouldn't shock you because that is our scale factor. You could check AB, but of course AB and CD are the same exact length because it's a rectangle. Let's check A prime, D prime. So A prime, D prime over AD. So A prime, D prime is 1. I'm sorry, let me cut that again. 2. And then AD, 1, 2, 3, 4, 5, 6. And 2, 6, divide by 2 on top, divide by 2 on bottom, gives you 1/3. So again, it ends up being the scale factor we wanted, so I can prove that we actually dilated this correctly. And I'm not going to check BC because that's exactly the same as one I just checked. Does dilation preserve or does it change? So does it change it or does it keep it the same? The orientation of the figure and the orientation of the vertices. Well, the orientation of the figure, aka does it face the same way? Well, yes, it didn't flip, it didn't rotate, it just shrunk. So it preserves the figure. And then does it preserve the origin of the vertices? So it goes A to B to C to D to A in the original, and then A prime, B prime to C prime, C prime to D prime to A prime. Notice that they're both going clockwise, so it preserves, whoops, fix my spelling. It preserves both. Okay. Next one. So this one we're going to dilate by a scale factor of 2. So we're going to write E, F, G, and H. We'll go find the points original. -4 and 2. F is at 4 and 2. G is at 3 and -1. And H is at -3 and -1. So scale factor of 2. Again, remember the math is just multiplication. So you're going to multiply the x and the y by both 2. So negative 4 times 2 is negative 8. 2 times 2 is 4. 4 times 2 is 8. 2 times 2 is 4. 3 times 2 is 6. 2 times negative 1 is negative 2. Negative 3 times 2 is negative 6. Negative 1 times 2 is negative 2. Plot the point and make sure it grew by a scale factor of 2, and hopefully gives us the same shape, which means we did it right. So negative 8 and 4, E prime, 8 and 4, F prime, 6 and negative 2, G prime, and negative 6, negative 2, H prime. And then if we connect them all, and again, you'll do a better job with a straight edge, but we look carefully, it preserved its shape. Of course, the image is enlarged, but it looks like we did it the correct way because we ended up with the same shape. So your rule, start with your x, y's, and then you multiply times 2 to the x and times 2 to the y. Next example of just practicing them. So we have k, I, and j. So k is at negative 4, negative 2, I is at 0, 4, and j is at 4, negative 2. So 4 and negative 2. Now we're going for the primes. We're going to multiply by 3 halves, or if you like it as a decimal, 1.5. So negative 4 times 1.5 would get you to negative 6. Negative 2 times 1.5 would get you at negative 3. 0 times 1.5 is still 0. 4 times 1.5 is 6. 4 times 1.5 is 6. Negative 2 times 1.5 is negative 3. So make sure we did this correct. So negative 6, negative 3, that's k prime. I is now at 0, 6, so I prime. And j is at 6, negative 3, which is j prime. Connect them. They're the exact same shape, which means that we did a good job. It's greater than 1, which means it should have enlarged, which it did. So I am confident we did a good job of our dilation. So we're going to take 3 halves times x. If you want to put 1.5 there, you can. And then 3 halves times the y. Next page. This time we're going to find the scale factor. They've already dilated for us, so we don't have to actually do all the dilations and drawing it again. We're just going to check. So this is our prime. It doesn't matter what you pick. I'll just pick L prime, M prime, and we're going to put it over LM. So L, 1, 2, 3, 4, 5. L, M on the original is 1, 2, 3, 4. So my scale factor has to be 5 over 4. Again, if you want to check, you can check MN. It'd be pretty hard to check the diagonal because that would be a square root idea. So let's check. The best is to check is the straight line, so it's easier to read. So P prime R prime over PR. PR prime is 1, 2, 3, it looks like. PR is 1, 2, 3, 4, 5, 6, 7, 8, 9. And 3/9 you can divide by 3 on top. So 3 divided by 3 is 1. 9 divided by 3 is a 3. So our scale factor is a third. And a good sign is, since the image shrunk or reduced, remember it has to be less than 1. So our scale factor is less than 1. And if we look at this scale factor, that's greater than 1, and the image grew a little bit. If they just give you the ordered pairs, we're going to do the same thing. So I taught you how to do it with line segments. With ordered pairs, you're just going to put the new over the old. So we can put 6 over the 9, which is the x's, and then reduce. So 6 divided by 3 is 2. 9 divided by 3 is 2/3. And if you want to double check, do it with the y's. So 8 over 12, divide that by 4, which is 2. 12 divided by 4 is 3. So both of them show that the scale factor is 2/3. Do it the same way here. You can do the x's or you can do the y's, it really doesn't matter. I'll do 12, the new one, over the original, since they're both can be divided by 2. So that means 12 divided by 2 is 6, 10 divided by 2 is 5. Or we can do it with the y's. Both of those are divisible by 3. So negative 18 divided by, and we're going to do a negative 3 to get rid of the negatives, which would be 6. And then negative 15 divided by negative 3 would give us 5. So notice that we get the same scale factor, which is 6/5. And we also can tell it grew in size. So we know that it had to be greater than 1. This one over here shrunk in size, it got smaller, so it means we have to have a scale factor less than 1. This one we can't check zeros, but we can check the x's. So the x on the on the new one is -9. The x on the old one is 1. Reduce that is 9. So this one grew at a scale factor of 9.